What's going on, everyone, and welcome back. Last time we started our shader class, we got a few methods to uh, change some variables inside of the shader, stuff like that. And this time we are going to work on matrices, which will also be passed to the shader. So let's go ahead and create a matrix class. And for right now, the only thing we're going to be doing with matrices are creating the orthographic projection matrix. So I'm going to call it matrix 4x4. So it's a 4 by 4 matrix. Inside of a float buffer would be 16 values. And I guess the first thing we can do is import the float buffer, since we'll need it to pass it to the shader. So we'll do import java dot nio dot float buffer. And there's only going to be one variable. It's going to be a private, come on, apparently my computer does not want to work right now. But all we're going to need is a private 2D array of floats. Some people use like M00 or M21. We're going to be using a 2D 2D array. So float M equals new float. We're going to use 4 values on each, and that is it. So then we'll just create the constructor and we'll say public matrix 4x4. Don't need anything in there. And then the first thing we're going to do is we're going to set the identity. Now, anybody that's worked in other game engines or anything similar, set identity is a very common thing you do. So then let's go ahead and create that function now. So it's going to return, or it's going to return void, sorry. I was thinking of another function. So set identity. And all this is going to do is it's going to uh, just set all the default values for this variable. And it's very easy. Once we create it once, well, we could just duplicate it and change values as we need. So the first one will be set to 1, and then we're going to go from 0, 0 to 0, 1, and so on. And all the rest of these values are going to be 0. And M0, 3 equals 0. And then all we have to do is paste it 3 times. Change this to a 0. Then come across, and it's just going to go diagonal down. So that to 0, that to 1, to 0, and that to 1. So you just have the ones going diagonal. And that's it for the set identity. Next, we will need a way to get a buffer of this information to pass it into the shader, or have the shader call the get buffer at least. So do public void get buffer, and we're going to actually have the shader pass in a float buffer that's already been created. All right. And for this, it is basically the exact same thing as this, except for we're putting it into a buffer. Actually, I'll change these values here in just a second. And then you just say buffer dot put, and then we'll put that in there, and then put dot put, and I'm just encasing these M values. And then that is how you do that. And like before, we will copy it. Oops. Don't need that. And we will paste it just like before. And I did something wrong. Yeah, I did. Yes. Okay. Needs to go like this. Sorry, I'm telling you wrong. So as it goes down, it just gets a greater X value, as you would say. So that it eventually goes to 3, 3. Okay, now set identity is done. Now we will just do the same thing here. So that's a 1. 1. And things do get a little tedious, but that's programming for you. 3. And matrices they're always a pain. So anytime you deal with matrices, there's just a lot of data you have to screw with. Alright, so that will get the buffer, or this will create the, or pass in the buffer, and we need to return it. There. Oh, you pain. Public float buffer. There we go. So now we're returning a float buffer. Wait. I don't need to return it because I'm using this buffer. I'm just storing the values. You need to flip it. Always flip your buffers. All right. So we need a way to create our orthographic matrix, but be able to pass in values that we want to use for screen coordinates and the size of the window and so forth. So just like other matrix classes, we can just create our own. It'll be basically exactly the same as what you would see like in the earlier versions of lightweight Java game library. So we will return a matrix. Call this ortho. So the first thing we need is the left, and then after the left we need the right, and then the bottom, and then the top, and then near and far. So left, say you wanted to start your like 0, 0 on the screen. Say you wanted it down here on the bottom left. So it'd be 0 over here for the left, and then the right would be the size of your window. And then bottom would be 0, and then top would be the height of the window. And then near, far, normally always stays the same. So now we need to do the calculations to create the orthographic matrix. So we need to create a new matrix. So matrix 4x4 matrix equals new matrix 4x4. And then we need to calculate the width, the height, and the depth. So to do that, it's pretty easy. It's just width equals right minus left. If I do that. And height equals top minus bottom. Depth equals far minus near. And that gives us our width, height, and depth. Now we need to set some of the things inside of the matrix. So first thing is there. Matrix dot m00 equals width times 0.5f. So a lot of people use width divided or divided by width or whatever. No. No. I'll just go ahead and do it. Okay. 2f divided by width. Yeah, we'll just leave it how you would normally see it, instead of doing things differently. I mean, it's just a matrix class for all. So then we set 1, 1 to 2 divided by height. And now we're going to set 2, 2 equals, then we're going to set it to basically the exact same thing, just for the depth. Now we need to set, is it 3? Yeah, I believe I set the 3s now. And then we're going to going to negative right plus left divided by width. We're going to set, oh Jesus, my fingers aren't working at all. Of course, when are they? Every time I'm recording a video, for some reason I can't type where the crap. Alright, so then it's negative top plus bottom divided by height. And then set M3 2 to negative far plus near divided by depth. And then we're going to return the matrix. And that is it for the matrix class. I mean, we may add things later, but I mean, honestly, that's really just about all we need for the moment. Okay, so now that we have a matrix class all set up, we need to actually get that orthographic matrix. So for now, as you can see, I've done some commenting. For now, we have, this stuff in here that we've created. A lot of this stuff will be moved somewhere else once we get going further, because we still need application settings and so forth, which we can just do that later. So after we set the material color, we are going to get an orthographic matrix. So need a matrix 4x4, call it ortho, new matrix 4x4, ortho. Now, in the last episode, how I was telling you that we're going to be working on the UI first. We're going to work on the actual editor before we start working on scene stuff, because we still need to set up game objects and transforms and all that goodness. So we want the left to be 0 and the right, we have it set to 800 by 600. So that'll be 800. Now the bottom, we want it to be 600 because we want 0, 0 to be way up here. So we want bottom to be up top. Now whenever we start creating our scene and stuff, this and that will be flipped. We'll just set the near to -1, and we'll set the far to 1. And that's it. That's all it takes to create an orthographic matrix. So now that we have that matrix, we need to be able to pass it into the shader. So here in just a second, I will set that up. But while we have this open, we might as well just go ahead and type it out. So it'll be shader.setUniform, just like we did before. We need to pass in the name. We'll just call it projection, and then pass in the ortho. And since we don't have that set up yet, we will do that next. That's the only bad part about commenting a lot is it takes up a lot of space. So inside of the shader class, we need to create another set uniform. So right down here after color, we will do public void set uniform, pass in the name, and then matrix for x4, and then we'll just call it, let's just call it M. Now, yeah, whatever. Doesn't really matter at this time. So just like before, we need the location of the variable. So we will do int location equals gl get uniform location, pass in the program, and pass in the name. Program. All right, so now that we have the location, we need to create a float buffer that we're going to pass in to the matrix, which will be buffer utils dot create float buffer. And it's going to be 16 values because it's a 4x4 matrix. Import float buffer. So now that we have the value, now we need to, or now that we have a buffer set up and we have the location, now we need to pass it in to the matrix. So I'm going to go m dot get buffer and then pass in the buffer. And then if the location does not equal 1, so if the location is not null, just like how we did with the color uniform, we are going to do GL uniform. Why do I keep doing that? Uniform matrix FV. Yeah. And we're going to pass in the location. Set that to false. And pass in the buffer. And after that, we'll buffer dot flip GL uniform matrix FV. Oh, forgot a 4 in there. There we go. So that is that. Now we have a method inside of the shader class that will set a variable in our actual shader. So there's going to be some math inside of here. We are not going to be using rotations. We may end up using rotations in the future, but currently we don't really need them because it's a 2D game. Most games don't use rotations, they use sprite sheets, which we will be doing. We could add rotation later, which it's seriously no big problem adding rotation at a later time. It's very simple. But keep in mind that if we do add rotation whenever we get to physics, there's a lot of physics calculations to uh, to check for collision between two OBB collision boxes versus using ABB or AABB, which is what we're going to be using to start with. We may add OBB in the future, and if you don't know what that means is AABB is an axis aligned bounding box, which just think of a square that never rotates. It's super easy to calculate that stuff. You don't have to worry about any kind of weird rotations or anything like that. And I mean, most 2D games just use AABB. There's no need for any of that other stuff. We will also be using like line colliders. So say we're going down at an angle, we can just collide with that line. That way we don't have to add in all the OBB nonsense. So just keep in mind it's a lot more work whenever you add rotations, especially since rotations really aren't going to give you that big of an advantage. But like I said, we may add it later, so don't be like, oh man, where are we doing that? Alright, so enough blabbing. Now we need to create the uniform. So go uniform mat 4. We called it projection. Now we need to, oh, I hate that, get where on the screen we want to position this thing, and we need to scale it a little bit because as we have it right now, one mesh is only one unit. So whenever we pass it in, it's going to be, 1 unit equals 1 pixel. So it's only going to be 1 pixel on the screen. So we need to scale it up, but we haven't gotten that far yet. So we'll just add it directly into the shader, and we can just change that information later. So we'll do vector2 world position equals, we'll get position times 10 and add a vector 2 of 100. So what this is basically doing is it's taking the positions of the vertices, because that's exactly what this variable is. It's just the position of the vertices. So we're taking the position of the vertices and we're multiplying it by 10. So that's going to make it 10 pixels instead of just 1. And then this right here is going to make it so that instead of rendering like in the corner over here, it's just going to drag it out a little bit. So this is the actual world position value. So world position and then the scaling factor. So now that we have that, we need to go over here under GL position. We need it to equal the projection matrix, which you always do this first. So projection times vector 4, and we need to change this since we now have a world position, and 0, 1. So that should be it. Let's go ahead and check this out. Hopefully I didn't mess anything up too bad. There we go, but it's black. Why is it black? Alright, give me just a second. Alright, I cannot, for the life of me, figure out what is going on with the color. So, if I figure that out before Sunday, I will definitely add on to this video before it's actually posted. But as you can see, the projection is working, scaling, everything. So right in here, we actually need to change something really fast, because right now we have it where the vertices are right in the middle of our quad. So we need to change this. We're going to put it to the bottom left, because remember, it's going to get flipped. So the bottom left will then be the top left of the projection matrix. So it's actually super simple. If it says negative 0.5, put a 0. If it says 0.5, put a 1. It's not complicated. So we'll change this. I got somebody blowing me up. I just put the wrong thing. Yeah, I did. I believe that's right. Yes. All right. And with the UVs, we're going to have to invert the Y. But luckily, this array right here for the vertices is the exact same thing for the UVs. I mean, you're not going to be able to see it right now, but I mean, so that makes it a lot easier. So now it is anchored at the bottom left. So then when the projection matrix gets a hold of it, it pops it up here. So then if we put 0, 0 as the position, so don't change the position at all, and we'll put it right here, going down instead of up. Alright, well, thanks for watching, and next time we will cover textures and possibly start getting a hold of, uh, start doing some of the GUI class, possibly, because it will primarily be our first objective once we get everything set up and going. Alright, so thanks for watching, and I will see you next time. Alright, so I found the issue. The issue is right here. It took quite some time to find it, but I finally found it. So if location does not equal 1, well, of course, it's going to eventually equal 1 because we're going to have more than one uniform. For some odd reason, I was putting 1 instead of -1. A -1 means that the uniform was not found. So then if we save that off, we press play, now we're getting our color. So, thank you for watching, and I'll see you next time.